All right, everybody. So let's go ahead and go over rational functions. Now, we want to make sure that we understand what rational functions are. The rational functions are that if you have some kind of rational function of p of x and q of x, it means you're kind of taking a polynomial divided by a polynomial, and the bottom polynomial cannot be equal to zero, because if it's equal to zero, then this will be undefined. So what I would like us to go through a little bit is kind of going through some steps of this rational function. So here's what we're going to do. We're going to start with this polynomial divided by this polynomial. And what I want to do is kind of look for some characteristics about this. And there's a whole bunch of characteristics, but let's look at them. So the first thing you could do is maybe we want to look at the domain of this rational function. Now, recall that the domain is all the x values, or the x, let's say the x intervals. So x intervals or x axes, the inputs. So where does this happen at? Well, we're going to look at the bottom. And the reason we're going to look at the bottom is because we want to make sure that our there's no vertical asymptotes. Because if there's vertical asymptotes, there's going to be some restrictions, and because you can't let this be equal to zero. So let's go ahead and find the domain. So the domain is, you're going to let x equals 0. So you're going to let the bottom equal to 0. Then you're going to go ahead and go and solve. So the domain is going to be, you could do all real numbers except 6. Now, another way you could do it is that you can go negative infinity to 6 union 6 to infinity. Now, there's those two ways you could do this. This says the same thing. Now, I know some of you might not know what this U is. This is called a union. It's a combine. It's kind of like you're jumping from one to the next. You're kind of jumping, and the union just says that from there you're kind of making a connection. And this is what this connection is that yes, you can't let it be 6, but on this side you can jump and make it almost 6, but to infinity. Remember, this is kind of like almost. We're not exactly on 6. We are approaching 6. Okay, so now we're looking at the vertical asymptotes. And the vertical asymptotes are pretty much the same thing here. And the vertical asymptotes is that, hey, I can't let our thing be 6. That's the vertical asymptote. So domain and vertical asymptotes are very close on this problem. And so is that a coincidence? It could be on this one. Does it always happen? No. But that means the vertical asymptotes, hey, you can't make you can't have it be 6 or 6. Really, I mean, that's kind of what you say for the vertical asymptote. So your domain is all real numbers except 6, and the vertical asymptote is not going to be. So that's kind of what's going on with this. So let's go ahead and do some more here. Why don't we go through maybe some whole? Like now, when I say wholes, I should be a little bit more sophisticated on this. I should say discontinuities, because that's kind of what you're looking at. You're looking at discontinuities because the discontinuities tell you more about this. So the discontinuities say, hey, do I have some kind of is it some kind of issue? That's what this means. So if I do this, what I need to do first is factor. So I need to factor, and I need to factor the top and the bottom. So I'm going to go ahead and factor the top and the bottom because the bottom is already done. Now the top, I need to do some factoring. So I know it's quadratic, and it's probably going to be something like this. something like this, and then it's going to be x, x, and then let's say what would be 24? 1.20, 1 and 24, 2 and 12. Let's think about this. I have to make 24. So what about 3 and 18? What about 4 and 6? Now, I bet you 4 and 6 is going to work. So I bet you this is going to be 4, this is going to be 6. And the reason I know, because I have to make the middle one. I have to make the middle one. And so this is probably going to be that. That's going to be that, because if I take those two, that makes the middle. So I think we got our factors. Cool, we got our factors. Now, to get a discontinuity, this is what's going to happen. Well, it looks like I have two factors on top and I have a factor on the bottom. Now, you could, if you really want to, you could put a parenthesis around there if that makes it interesting. And then this is going to go away because there are two factors. Now, it's kind of like saying, hey, you know what? I have x divided by x. Well, remember, that's just 1. That's not 0. So this is kind of the idea. You want to kind of cross those factors out to make 1. So here's what you're going to have for a discontinuity. If you cross these out, that means if I go ahead and set one of these equal to 0, that means my discontinuity is going to happen at 6. So I'm going to have a hole. I'm going to have one hole or one discontinuity at 6 and what? Okay, I'm going to have it at 6 and what? I mean, that question, this would be a question mark. So you're going to go back up to here, and what I'm going to do is kind of cover this one up. See how I'm covering the rest up? I'm going to go to the leftovers. I'm going to go what's left over. And I'm going to go ahead and take this 6, and I'm going to go ahead and plug it into this one. I'm not going to plug it into the rest of it, because if you do that, do you see why? If I plug that 6 back into this one, I'm going to have undefined. I'm going to have 0. I can't have 0 here. So you see how these cross out? That goes bye-bye. If I plug it into there, that's 6 plus 4, which is 10. So that means if I plug it in, I get 10. So I have a hole right there at 6 comma 10. If I were to graph that, by the way, that hole is x comma y, if you think about it. Okay, so we found the hole, we found a discontinuity, we found a domain. Let's go and find one more aspect to this. So this aspect is going to be, what if I find the zeros? Now the zeros are kind of like think about like roots or solutions. Where do those happen? If you don't mind, I'm going to kind of rewrite this because we can see it. So this is what our problem looks like. What I'm going to do is take this top piece, and I'm going to make that equal to 0. To find the zeros, I'm only going to do the top. I'm not going to do the bottom, because the bottom, if I set that equal to 0, you already found that. That gives you your domain restriction. That gives you your vertical asymptotes. I'm only going to set that one to 0 when I find the zeros. So we already factored this, and the factors were what? This and this, right? Okay, and if I set those equal to 0. Now, I hope that you remember that if I solve this, those are what I get if I solved them. So if I solved, this is what I get. Now, I want you to understand one thing about this. I want you to put like a little note here. You can't have that one. So cannot have this one because it was a what? It was a vertical asymptote, but turned into a hole. Okay, it turned into a hole. and you're going to say a hole is greater than a vertical asymptote. So that's kind of what's going on with this. So now you only have one 0, which is at -4. So we have all this put together. And what I'm going to do is that I'm going to put it together. I'm going to graph everything I have. I'm going to graph everything I have. So here's my graph. I'm going to go ahead and look at my directions here. My domain says I have at 6, I have a vertical asymptote at 6. So I'm going to go on my graph here. And I'm going to go 1, 2, 3, 4, 5, 6, and then I have this. So this is technically what I have so far on my vertical asymptote. Now, where does the hole happen? Well, the hole is going to be, what is it? 6, 10. So if this is 6, there's going to be a hole right here. So there's a hole at 6, 10. Now I'm going to do this. I'm going to take this out now, because remember what I said right here? The hole takes everything over. So there's just going to be a hole here. There's not going to be a vertical asymptote. So technically this vertical asymptote is gone. It's blank. So you just have the hole there. So we still have something happening here at 6, 10. But what else did we find? Well, let's see. We found our domain, which is everything but 6, but there's a hole there. And also we found a 0. So one of our zeros got canceled, but look at this. See that guy right there? That is a 0. So at 1, 2, 3, 4, there's a hole there. I mean, not a hole, but a root. There's a root right there. So we have to be careful where we put our stuff, and also we got to make sure that where does our graph look like? What's going on with our graph? Now you could graph this, or you can make a table of values and go from here. Now I'm not going to do that for you because it's not important right now. I really want you to understand that domain, you can find vertical asymptotes, you can find any discontinuities, and find the zeros. That's really what I'm looking for right now. If you are looking at this and want to know how to graph it, plug graph some points in here. We can't use 6, so that gives you does not exist. Sorry for my typo. Does not exist. You can't get there because this is a vertical asymptote, so you can't put 6. But could we put 0? Could we put 1? Could we put 2? Could we put -3? Could we put 4? Yes, you can. And so what's your graph going to look like? It's going to look like some kind of weird thing. Now, I don't want to kind of go into that too much, but you could go to like Desmos. You could go to like Desmos.com. So you could go to Desmos, and you could graph this if you like. It's not going to be required to do that right now. But that's kind of the idea. That's what we're trying to find for all this. So let's so we can kind of graph it if you like. I'm not really worried about that, but if you have a teacher that wants you to graph this, you know darn well that something has to go, the graph has to go through this hole. And so when you are doing this, you want to be very careful, because at the 10, I bet you if you put a graph in, so I'm trying to think what your graph would look like. Because if you have something at -4, which is right there, -4 is there, your graph's going to kind of go like this and go up. And then maybe something like this, if you do that. I'm just kind of ballparking here, but you can go on Desmos and you can kind of figure this out. But your graph has to go through that hole, and it has to go through that root to be a function. All right, so I hope this makes sense, and go ahead and try some more of these and just follow this little script if you want. All right, I will see you